The second way of doing finite differences from a table is sometimes you're not given the y-intercept, so you have to do a little bit of backtracking. So you still do the first couple steps as you did before. You would take and find the difference by taking the y minus the one above it. So this would be 14. When I subtract these, I get 26, 38, 50, and 62. Now, obviously, these are not the same difference the first time, so I'm going to have to do it a second time. So when I do that, 26 minus 14 is 12, and when I do these, I keep on getting 12. So now I know for sure from the last video we talked about, if I take half of this second difference, that's going to be my a value for my quadratic equation. So again, y equals ax squared plus bx plus c is my standard form. So half of 12 would be 6. Now to figure out our c value, we're going to have to go back to 0, and we're just going to kind of follow this pattern of what are the missing numbers here. So when I subtract these two numbers from each other, I need to get 12. So 14 minus what is 12? Well, that would have to be 2. And then now when I subtract these two numbers, I have to get 2. So 3 minus 1 would give me 2. So then I know my y-intercept in this case, by doing a little bit of backtracking from this pattern, has to be 1. And then again, what I like to do is use 1. And the reason why I'm using 1 is because when I put in for x, it's not going to change any of the values. So 1 squared is 1 times 6 is 6 plus 1 is 7. When I look at 1, I'm supposed to be at 3. So to go from 7 to 3, I would have to subtract 4, and that becomes my b value for my equation. So the final equation for this particular table is y equals 6x squared minus 4x plus 1.